So a non-homogeneous second-order differential equation with initial values. So in this case, we're not only going to be solving for that letter that we're looking for, we're also going to be solving for the C1 and the C2 that are going to be associated with the y sub c. Okay. All right, first part is that auxiliary equation. All right. So m squared plus 4m plus 5 is going to equal 0. I don't see a good way to factor this off the top of my head. So why don't we have a second look at it? So, let's use the quadratic equation, excuse me. Okay. So m is going to equal negative b plus or minus the square root of b squared minus 4ac divided by 2 times 1. Okay, so this part in here becomes 16 minus 20. I'll do it in 2 steps. Okay. So this is going to be negative 2 plus or minus the square root of negative 4 divided by 2. But the square root of 4 is just 2. So this thing becomes negative 2 plus or minus I. Okay, so we're getting into the complex realm at this point, but remember, we go into the complex realm, we just end up involving sines and cosines because of Euler's formula. So, the y sub c that we're looking for is e to the minus 2x, that's the real portion of it, all right, and then multiplied by c1 cosine of x plus c2 sine of x. Okay. So the I is just being multiplied by 1. If it was 3i or 4i, whatever, then you put that 3 or 4 inside the cosine and the sine. Okay. So that's our y sub c. All right. Now, you look at the right-hand side of the problem, and this is the idea behind method of undetermined coefficients, is that there's an e to the minus 4x on the right side of this problem. So whatever solution I plug in for the value of y into this differential equation, I want the complementary part just to go to 0. But I want the particular part, as I plug it into that differential equation, I want it to spit out an e to the minus 4x. So that means that y sub p is of the form a e to the minus 4x. Oh, sorry. All right, so let's go ahead and take its derivatives. Because each time it spits out a negative 4. Okay, so we have our derivatives. Now, what we're going to do at this point is we're going to plug our derivatives back into the original differential equation that we were dealing with, and then we're going to set it equal to 35 e to the minus 4x, and we're going to try to figure out what a is. Okay. So we're looking at this. Y prime prime, 4y prime, screen. Plus 5y is going to equal 35 e to the minus 4x. Okay, so we have 16a e to the minus 4x on the screen. Okay, now plus 4 times negative 4 e to the minus 4x plus 5, now, sorry, there's an a in there, a e to the minus 4x, okay, and that's going to equal 35 e to the minus 4x. Okay, now 4 times negative 4, that's going to turn into a negative 16. And so this guy and that guy are going to cancel each other out. And so what am I really left with on this problem? It's that 5a equals 35, or that a equals 7. So, what do we have from this point on? Okay. Okay, so we have our y, which is the sum of the complementary and the particular. All right, so now we get down to the point where we have to figure out what C1 and C2 are. Okay, so we're not done with this problem. So at this point of the problem, we're going to take into the fact that y of 0 equals negative 3, and that y prime of 0 is going to equal 1. Okay, let's treat the negative 3 first. So, okay. Now, when I plug cosine of 0 is 1, e to the 0 is 1. So this first guy is just C1. And then the next guy is plus C2 times 0, and then plus 7, because e to the minus 4x 0 is minus 4 times 0 is e to the 0, which is just 1. Okay. Okay. So if I subtract the 7 over to the other side, that's going to give me that C1 equals negative 10. All right, this next one is a bit trickier. So I might have to do 2 lines just so everybody can see the full thing, because I don't think I can fit this on 1 line. Okay, so let's have a look at what y prime is. Okay, that's just the derivative of the first term. Okay, now we have to consider the derivative of the next term. So that would be minus 2 c2 e to the minus 2x, now multiplied by sine of x, and then plus c2 e to the minus 2x, now the derivative of sine is cosine of x. Okay, so on both of those problems, you're going to have to do the product rule on both of them. Okay? And then we have to consider our guy at the end. Okay? So this is going to be minus now 28 e to the minus 4x. Okay? Now, when we say y prime of 0, okay. All right, now, off the screen again? Yeah. Okay. So we're going to have to evaluate this whole thing at 0. And one of the things to notice, I'll do it with all the steps and everything, but your signs are going to disappear. Okay, and the cosine of 0 is 1, and e to the 0 is 1. So really what terms are we going to be left with is this guy, and this guy. Okay, so the first one is going to be negative 2 C1, and I know that we'll turn that into 0 in a second. Okay, then this guy would be minus 0, and then plus C2. All right, so that's the top line and the middle line, and then minus 28, and all of this is supposed to equal negative 3. Okay, but we know what C1 is. So let's have a look at this. Let's rewrite this problem down. Okay, so this is the problem that I'm looking at right now. So negative 2 times negative 10, and then plus C2, and then minus 28 is supposed to equal negative 3. Oh, wait, no. That's going on. 1. I was thinking about the other point. Because it says at the top, and we scroll back up, y prime of 0 equals 1. So it should be 1 at this point and not 3. Excuse me. Okay. Okay. So that's a positive 20 plus C2, and then minus 28 equals 1. And so C2 minus 8 equals 1, or that C2 equals 9. Right? I don't want to waste a whole page writing the answer down something for this page. Okay, so we have our C1, we have our C2, we have our complementary and our particular solution. So we have a complete solution to this problem. So y is going to equal, okay, so C1 was negative 10. So we have negative 10 e to the minus 2x times cosine of x, and then plus 9 e to the minus 2x times sine of x, and then plus 7 e to the minus 4x. So it's like, how many pages of notes was that? I think it's only about 2, 3, 2.5.